Hi AP students. I really wanted to go over this problem in your homework. I believe it was number 62 in class today after your quiz, but things just took a while and I didn't get a chance to do that. So instead of doing problem 62, I'm going to do one very similar. And this is our first video of the year. Are you excited or what? And I can put a video up like this, maybe one or two per chapter upon request. Alright, so here's the nature of this problem. I know I had some questions on it, but IQ scores, or at least it's like problem 62, IQ scores are thought to follow a normal distribution. However, kitties, sorry, those are my cats, I'm at home. However, yeah, relax. However, statistics on IQ scores are hard to come by. You take a IQ test and you score 118, which places you in the 90th percentile. Your friend's younger brother, he's not quite as smart as you are, since you're an AP student. He takes the test, scores an 88, and that puts him in the 28th percentile. What is the mean and standard deviation of test scores? Whoa, that seems like a big jump, doesn't it? How do we don't know the mean and the standard deviation, how do we follow this? How do we find this? I set these videos up as, I call them try-alongs, that I encourage you to pause the video, work on your own, and then you can replay and just watch me solve the rest of the problem. But really try this on your own. Don't just, watch me and listen to me. So take a minute now, see how you get started. How would you get started on a problem like this? All right, and then I'm going to work it out. Did you pause it? Are you back already? Hey, welcome back. All right, so this is how you should start. At the very least, start out with a sketch. We know we have a bell curve. We have some unknown mean, and we have some unknown standard deviation. But what do we know? We know we had a score of, I have to go back and look, our score was 118, your friend's brother was 88. So your friend's brother here got placed in the 28th percentile. So that's going to mean the area down here to the left is, this little area is 0.2800. You, however, being an AP student, did much better than that. You got placed in the 90th percentile. Even though I know you could have done better. You know you could have done better. That's okay. Better luck next time. The test was rigged. Alright, so that area to the left is 90%. So what can we do here? Well, let's find some z-scores. So it's still an unknown. I'll call this x1, I'll call this x2, so we got to find some z1 and some z2 such that the area to the left of z1 is 0.28 and the area to the right, area to the left of z2 is 0.90. So if you have your table, you can use your table, and please pause, see if you can find the right z-scores here. You can use your table or you could use your calculator. I actually don't have my calculator with me, so I'm going to go for the table, but if you wanted to, you can inverse norm 0.28, and that's all you have to do. Then you're going to get this z-score, and you can also inverse norm on your calculator to get wait, gotta be neat. Inverse norm 0.9. You can just leave it like that. Don't need all the zeros, and you can find z2, the other z-score. I, however, am going to pause the video myself and look on the table. Okay, did you find your z-scores? I calculated this. I got z1 to be negative 0.58 and z2 to be 2.33. Hopefully you got those same z-scores as well. Okay, next step, we kind of look at this and we go, wait a second, okay, so we have some z-scores, but I still have two unknowns. If I take a look, well, let me put it this way. If we go, okay, z1 is going to be x1 minus mu over sigma, well, even if I put in my values for z and x in this case, which I know, I'm still left with two unknowns. But guess what? If we have two unknowns, we need how many equations? That's right, two equations. Oh, systems of equations. Whoever thought I'd need to know algebra to do statistics? Oh, man. Pause it. See if you can do it from here. Pause it, because I'm going to keep going. I hope you already paused. You're back already. You paused it? No, you didn't pause it? Pause it? Pause? Yeah, pause. Clause? What is that? The cat's paws? Okay. So let's put in some numbers here. Negative 0.58, and that's going to equal our little brother was 88 minus some unknown mean times some standard deviation, and then we had positive 2.33. That was you who got 118 minus the mean times some unknown standard deviation. I'm going to go to my next screen. We're going to multiply sigma by both sides here. So I got negative 0.58 times sigma equals 88 minus mu. You know what? I apologize. I'm backtracking. You could write another line, but I'm just gonna. I used the z formula. We could have just as easily just used this formula, and in fact, it's just going to be a little easier. Sorry, I'm backtracking here, but all you needed was another step, and you'd get it in that form. So we had 88 equals the mean plus our first z is actually a minus z, so that's minus 0.58 times sigma, and then the other score was 118 equals the mean plus 2.33 sigma. So if you recall from algebra, there's a few ways you could solve an equation, a system of equation like this. There's substitution, elimination, there's Gaussian elimination, there's the inverse matrix method, there is just shaking it around until you get an answer. No, you don't want to do that. But I think the easiest way to solve this guy is going to be through elimination. Why? Because we have a 1 mu and a positive, we have these two mu's here. Essentially, if I take this equation, subtract it from that equation, we're going to get rid of these mu's. So what I don't know, I hate multiplying, so what I do instead is, I hate subtracting, so I just kind of make everything negative here, and now I can just add things, so this plus sign will turn into a negative, but hopefully you've learned your own methods to do this. But so I have 88 minus 118, that's really hard. I think that's negative 30 if I did my math right. These two mu's, we add them together, they are gone, they're 0. And now we subtract, negative 5.8 from negative 2.33. How do I do this without a calculator? Same, add up. I have to add these two. So it's going to be 2. I'm going to get a 1 over here, so I got to go. Oh man, I hope I'm doing this right. I'm going to be really embarrassed if I'm wrong. Did you guys get that? Am I right? Should check it in just a minute. And I will. I'll pause the video and get on my calculator, because I'm definitely not going to be able to do this last step in my head. It's dividing by 2.91 both sides, even though it should be, I don't know, I'm going to guess about 10.6. I don't know. I'm going to pause the video and calculate it. Hey, I'm back. It's like I never paused the video, right? Did you pick up on my mistake? You were yelling at me. Don't worry, I would have figured it out sooner or later. Yeah, that's right. That's supposed to be negative, so I'm dividing by negative. How did I know that? Just as I was putting numbers in, it was easy to find my mistake, because had I divided by positive 2.1, I would have gotten a negative standard deviation, and you know that's wrong, right? But good news, at least I got the 2.91 right. And I wasn't terribly far off with my guess of 10.5. It was 10.31. And it's not negative anymore, excuse me. Okay, that's fine, but it's not negative. The negative's gone because we divided by a negative, so our standard deviation we have found out to be 10.31. Alright, we're almost there, right? Last step is we can use plug 10.31 back into either of these equations. I'm just going to pick on the first one, and then we will solve for our unknown mean. So let's do that. 88 equals mu minus 0.58 times 10.31. And why don't you pause the video if you still want to calculate this. I'm going to pause, and I'm going to magically come back with an answer. I'm back, and I got my magic answer that the mean is 93.98. So there you have it. Maybe we can write this with in a sentence. IQ scores follow an approximately normal, or I think I said in the problem that they do follow a normal distribution, with a mean of 93.98 and a standard, that was the letter a standard deviation of 10.31. Yeah, you thought my handwriting was bad in class. You should now you see how bad my handwriting is with a stylus on a mini iPad. So just one big warning I want to make about this problem is we were able to find the mean and standard deviation essentially with two scores, knowing the score and the percentile. But this was stated in the problem, IQ scores are thought to follow a normal distribution. A lot of times we make this assumption because we know a lot of things do follow a normal distribution, but just realize it's really, in a sense, just a assumption. You don't know for sure without some real good statistical analysis whether something follows a normal distribution. We kind of talked about the QQ plots, or the normal probability plots, and that's essentially the idea. But we would need a large sample of IQ scores and a good diverse sample that's representative of the entire population. So what I'm getting at is that you don't know if necessarily if you know those same percentiles, is the distribution, I'm just going to draw a few of my own here, is it maybe kind of uniform, maybe something like this, kind of uniform? Is it some kind of weirder, what was that? That wasn't what I meant to do. Is it maybe some kind of weirder shape that we don't know? Is it bimodal? Is it trimodal? What is it? Who knows? So we make these assumptions sometimes because we want things to follow a normal distribution, because many things in life do, and they're easy to work with. Alright, I'm done talking. Alright, I hope you enjoyed it. Hope that helped, and happy studying.